Number 8 said that in the circuit diagram that the battery provides a constant delta V of 50 volts. Capacitor 1 and capacitor 2 are initially uncharged. Switch S1 is closed, charging the 100 times 10 to the negative 6 F capacitor C1. Then S1 is open, disconnected the battery from the circuit. Following this, S2 is closed. This is the withdrawal diagram. Now part A asked, before S2 is closed, what charge is stored on C1? So, in order to make it clear, we need to withdraw the circuit. Now, in this part, S2 is not yet open, so the diagram is basically a battery connected to a capacitor. And that's the S1 that's closed, so it's connected. Now we don't have to care about this part because it's disconnected. Now it's given the delta V is 50 volts and C capacitor 1 is 100 times 10 to the negative 6 F. Now just simply plug in the equation. C equals to Q over V. And we isolate the charge and we get C times V equals to capacitor 100 times 10 to the negative 6 F times 50 volts. And we get the charge stored in C1 is 0.005 coulombs. Now part B is the tricky part. Part B says after S2 is closed, the delta V across C2 is measured to be 35 volts. Determine the capacitance of C2. So it's basically saying that the battery is now disconnected. Now we have two capacitors sharing the charges. That's the first capacitor. That's the second one. The switch is closed. Now we get the charge stored on C1 from the first part, Q1 coulombs. Now this is actually a parallel circuit, if we think about it. So Q1 equals Q1 plus Q2. After the switch is closed, Q1 plus Q2 equals to the original one. Plus Q2. 5 coulombs. Now the voltage is dropped from 50 volts to 30 volts, and that's not only in C2, it's also in C1, because it's a parallel circuit, so the voltage in each capacitor is the same. Volts. So now Q1 plus Q2 1 equals to capacitor 1 times V1. And C1's given, which is 10 times 10 to the negative 6 farad, times the voltage of the first capacitor, which is, in this case, 35 volts. And now we get a charge to be 0.0035 coulombs. And that's for Q1. Now Q2 will simply use the total charge at this point, which is 0.005 coulombs, minus Q1 equals to 0.0015 coulombs. V2 equals to V1 equals 35 volts. So C2 equals to Q2 over V2 15 coulombs over 35 volts. After solving this quantity, we would get 43 times 10 to the negative 6 F. And that's the answer to this part.